Hello guys and welcome back to the channel. Today what we have brought for you is an interesting build based on electronics and a small microcontroller called Arduino. So Arduino is a small microcontroller unit based on Atmega microcontrollers, and you can basically do multitasking with it. You can control devices, you can detect data from the sensors, you can control actuators such like motors and all. So today what we are going to do is we are going to create a basic robot using Arduino. For the robot, I would like to thank our friends and partners Barnabas Robotics, who are based out of USA. So let's get started. So first thing that we are going to do is we need to print the body of the robot. So for that what we are going to do is we would need the files to print it. So I have these files provided to us by Barnabas Robotics. You can download these files from the description. I will leave a link over there. So there are different files that you can see right now. First one is the arm of the robot. So this is basically the arm. Second thing that we have is the body. So this is the body of the robot. It's basically open from the back side so that you can insert all the electronics and everything in place. Third thing that we have is another arm. So right and left arm you have over there, and it's basically flat from the bottom, so you can easily print it using a 3D printer. You don't need to provide any kind of support while printing it. Next thing we have is the hand. So these have to be attached to the arm with the help of a glue. And the last thing is the head of the robot. So what we are going to do is we are going to put these in our 3D printer software, process them, and we are going to 3D print all the files. So I am using a flash force printer, so I am using flash print for this. No, I won't be downloading the updates. So I'll print it in two parts. First I'll print all the small parts together, and then I'm going to print all the big parts. So just like head and body, I'll print them together, and arms and everything I'll print them together. So first thing is the repair. Okay, first thing is this arm. I might need to flip this because the flat part is on top. So rotate and yes. So this will become my right arm, and okay, next part that I'm going to import in this is the body we can print later. So let me just delete this, and this is my another arm. Yes, repair. Okay, and I can move it to the side like this. This is ready. And next thing would be the hand. So because the flat part is over here, I might need to rotate this to stand on the flat part. So X rotation, move on platform, and I can simply copy and paste this for left and right because it's eventually the same. And the last thing would be to get the head on this one. So rotate, X, move on platform. Okay, so I'll print this one together and body separately. So let's just get these files ready. So now I have inserted my memory card in the system, and what I'm going to do is I'm going to print this one right here. So I'm gonna select print. I'll be using PLA for printing. standard. Let's just see the more options. Shells is fine, infill is 15%. Let's just reduce it to 10 because we don't actually need a lot of integral strength to this. Triangle, speed, temperature, I'm gonna increase to 215 because I have a cold bed printer. This doesn't matter. And yeah, and I'll just simply press OK, and I'll save it as Barnabas 1. Alright, so it is saved. It is roughly going to take 4 hours and 7 minutes to basically print this part, and I think it's gonna be fine. Yeah, I won't need any kind of support in this. So we'll just go back, and I'm gonna delete all this and import the body part as well. So we are going to print the body as well. I think this is the one. Yeah. So I'll need to flip this upside down because we won't want to have all these supports filled up over here. So I'm going to rotate this body part. Yeah, and move it to platform. And I think this should work. This should give us a pretty decent 3D print. If you want to order the complete kit, the entire kit link is given in the description. You can go ahead and buy it. The lead time for the entire kit is around 5 to 6 days. So once you order it, it is going to take 5 to 6 days to ship it to your location based on where you are. So I'm going to print this one as well. Same settings. Infill is going to be 10%, and I'm simply gonna hit OK and rename it as Barnabas 2. I think this should take relatively less time as compared to the last one. Yeah, it's gonna take 3 hours and 17 minutes. So what I'm gonna do now is I'm going to print these files and enjoy the time lapse of 3D print. Alright guys, so while everything is printing in the 3D printer, I'll show you some other components that we are going to use in this build. First one right here is something which we can denote as the brain of our robot. This is an Arduino board. So speciality about Arduino board is that it is a microcontroller. You can code it in embedded C. Basically Arduino has its dedicated software for coding it, which is absolutely free. Second thing about the brain of the robot is it is just like a brain in human beings, because in our the brain in the human beings processes all the signals that is being sent to them, and it helps us in taking a decision. So similarly Arduino will help our robot to perform actions. So in human body the input is basically our sense organs, which is the sense of smell, the sense of sight, the sense of taste, the sense of touch, and the sense of feeling, or what do you say, the 5 sense organs which are over here. And the output is in the form of our mouth, is in the form of our arms, of our legs. So to move the body parts of our robot, we are going to use something called as a servomotor. So a servo motor is basically a motor which rotates from 0 degrees to 180 degrees. It moves in angles. So this will help us in rotating the arms and head of our robot. Now a servo motor usually comes with these 3 wires. If you can just look over here. So one is yellow, one is red, and one is brown. The yellow one is the signal wire. Okay. And the brown one is watt, which is connected to the negative terminal of power supply. The red one is the one that is connected to the positive terminal of power supply. So this servo motor right here is a 9G servo motor, and this is going to work at 5 volt supply from Arduino itself. So Arduino gives out a power supply of 5 volts. Now to connect multiple motors at once, we are going to use something called a sensor shield. And sensor shield is something which is going to sit on top of all these pins on my Arduino board, and it will make it possible for me to connect multiple motors at once. So this is what a sensor shield is. As you can see, there are dedicated pins on each pin number of Arduino, and each pin is having a V pin and a G pin. So this will be my positive pin and my negative pin. So let's make the connections, and let's assemble our robot and code it. So the first step in assembling the body part for my robot would be to mount the center body with the motors. So I am going to use this part which is the central body, and I am going to insert the motors in such a way that they are protruding from one side. So as you can see the shape of motor over here, let the camera focus on it. Yeah, so there is this indent on this, and the same indent can be found on the body of the robot. And at the bottom of the body you can see this hole over here. We can bring out the wires from that hole. So to hold the servo motors in place, I am using something called the M2 bolts. The M2 bolts are easily the best thing to hold the servo motors in place. It's really thin. I don't know why the camera can't focus on it. Just a second. Yeah, so this is an M2 bolt, and to hold this in place we will need something called the M2 nuts. So M2 nuts and bolts to the rescue. They are going to help us mount the motors in place. So to assemble the robot, I took help from Tripti Vashne, who was our maker evangelist, as she has thin fingers, and it would be really helpful to assemble the robot quickly. So right now what we are doing is we are putting in the left and right side of the servo motors. We are putting the nuts and bolts from inside, as it will be really helpful for us. So yeah, and also like we are using left and right side to be mounted first, because otherwise it will not create any obstruction while mounting the motor on the head side. So taking out each motor from the back and mounting them on the left side and the right side for arms of the robot. The process is fairly simple, and it hardly takes 5 minutes to assemble everything together. The last step would be to mount the motor on the head side. Carefully take out the wires from the bottom hole which is given in the body of the robot, and just put the motor over there. And this time we are going to put the bolts from the top side so that it's not obstructing the movement of the head of robot. You can simply slide in the head on the top, and the next step would be to join hands with arms. For that we are using just a drop of super glue. Alright, so the structural assembly of our robot is ready. Now what we are going to do is we will be programming this robot. For that I'll need to make the connections. So on the sensor shield right here, this is the sensor shield that I'll be using, and I'll be connecting the head to pin number 2, and as usual, like I explained earlier, the what do you say, red cable will go to the V, brown cable will go to G, and yellow cable would go to signal. So I'm gonna make the connection 0 1 pin number 2. So ground, volt and signal. It's from the top, the denotation is like that. You can also check out the schematic which is being shown on the screen right now. So I'll be attaching the cables just like that. For the right hand, I'm going to go with pin number 3. So I'll just check which is the wire for the motor. I believe this is the one. Yeah, this is the one. So I'll go with pin number 3 for this hand. For the left hand, I'll be using pin number 4. And done, the connections are done. Now all we need to do is we need to put the sensor shield on top of our Arduino board. So we'll just take it out from the foam base and simply plug it in, aligning the pins together with each other. So it will go something like this. And once the shield is sitting on top of the Arduino board, what we are going to do is we are going to connect the USB cable over here and write the code that I'm just about to show you. This is how we are going to connect our Arduino to the computer. Whatever computer you have, you might have a laptop, you might have a desktop, you might have a Raspberry Pi which you're using as a desktop at your home. So okay, as soon as you plug it in, you will hear a crackling noise from the servo motors, because they have got the supply and now they are ready to be programmed. Now what we will be doing is we will open the Arduino IDE on our system. You can download Arduino IDE from the link in the description. It's absolutely free. You don't need to pay a single rupee for using this software. And basically this is what Arduino IDE looks like. So this is an old program that I was working on. I'll open a new window so that it's easier to understand. We can go to File, we can go to Examples, and we can go to Servo, and we'll select Sweep. This is the code which is pre-included. So what this code basically tells us, it creates a servo object to control a servo motor, and what we can do is we can create 3 servo motors in this. So servo space my servo 1, alright, and similarly I can create 2 more servo objects over here. So I'll select this thing, copy, and I'll just paste it again, Control V and Control V. So I'll create 3 servos over here, my servo 1, my servo 2, and my servo 3. So these are the 3 servo motors which I'm going to use. Number 1 is on the head, number 2 is on the right arm, and number 3 is on the left arm. This is position, so the initial position where you want your servo motor to be, which is at 0 degrees, where I want it. So my servo dot attach, so as you can see, it is written attaches the servo on pin number 9 to the servo object. So my servo 1 would be attached to pin number 2. So here I'll modify 9 to 2, and similarly I'll use the same command for my head, and so this is my head. Okay, it attaches the servo on pin number 2 to the servo object, and yeah, my servo 2 dot attach 3. Alright, so pin number 3 is my second servo, and my servo 3 dot attach at pin number 4. Alright, so these are the 3 servo motors that I have attached over here on my robot. Now void loop. So void loop is something which is basically a loop, alright, and what it is going to do is it is going to run my servo motor from 0 degrees to 180 degrees and then back from 180 degrees to 0 degrees. So there are 2 for loops over here. Void loop is the function that runs again and again repeatedly. So like I told you that Arduino is a microcontroller, and it basically runs tasks again and again in a loop. So what I'm going to do is I will modify this code as my servo 1 dot write pause delay 50, and below that I'm going to define my servo 2 dot write pause. Pause is basically a variable. I'll explain the entire code again to you once I'm finished writing it. My servo 3 dot write pause. Alright, now this is for the first for loop. So inside the void loop we have declared another loops to run this thing or run this robot from 0 degrees to 180 degrees, and now we'll do the same for 180 degrees to 0 degrees. So I'll explain the code to you now, what is happening over here. So what is happening over here is basically we have created 3 servo motors inside this code. My servo 1, my servo 2, my servo 3. These are definitively 3 servo motors. I have declared a variable called pause, which is the position of the servo motor, where is the shaft of servo motor, whether it is on 0 degrees or any other angle, and I have initialized it with 0. Alright, now what I have done is I have attached the servo motors on pin number 2, 3 and 4, and now I am running 2 loops. First loop would be, it will go from 0 to 180 degrees, and it will basically rotate my servo motors from 0 degrees to 180 degrees. So for pause equals to 0, it will start from 0. Pause is less than equal to 180 degrees. If my pause is equals to 180 degrees, pause plus equals to 1. So if it is 0, and the next time it comes to the loop, it will become 1, then it will become 2, it will become 3, it will go like that. Okay, so it will write all these values on the 3 servo motors, and there is a small delay of 15 milliseconds to let Arduino breathe a bit. And similarly, there is what do you say, the same thing is happening. It is going from 180 degrees to 0 degrees. So what I'll do is I'll select the port on which my Arduino is connected. It will show up in this. Yeah, it's connected on COM number 7. And I'll select the board as well. So I am going to select UNO because I'm using an Arduino UNO board. So now what I'm going to do is I'm going to upload this code, and as you can see, it is uploading. Okay, it is uploaded now. Right, so my code is uploaded, and now I want to show you how my robot is behaving. So it will keep doing this. The head is trying to move, but I think the glue went inside, so it is not able to move. So yeah, that's pretty much about it. And I feel that this is a very interesting build. And each time you will reset your Arduino board, it will start from the beginning. It will take the motor to the 0 position, and then it will start rotating it again and again. It will go from 0 degrees to 180 degrees, and it will try and move the robot's arms and its head. Alright guys, so I hope you enjoyed the build of our little buddy over here, and the link to the entire kit of this robot is in the description. You can go and buy from there. Also, you can download all the softwares and resources that are shown in this video in the description. All the links have been given in the description as well. Before you go, I'd request you to follow us on our social media handles right here, and reach out to us if you need to build anything at any point of time. The contact details are also in the description itself. So we'll see you in the next video with an interesting new build. Bye bye.